Hey, how are you doing? We're solving today 9005 lead code count island. So you're given NM binary matrices grid containing only zeros and ones representing what an island. An island is a group of ones connected. Okay. The island grid considered sub-island if there is a grid 2 considered sub-island, if there is a grid 1 containing all the cells that make up this island in grid 2. So, example, in the present of the grid on the left is the grid 1, and the grid on the right the grid 2. The number ones called the grid 2 are those considered to be part of sub-islands. There are 3 sub-islands. So, 1, 2, oh, there are different sub-islands, okay? Okay, so this is interesting. So, how can we solve this? We could use DFS to enumerate islands. In grid 1. Then we can use DFS to enumerate islands in grid 2. But we will check if part of the island is, so this is like inconsistent island and it's 3 and they're not connected, and here is answer is 3. So do we really have to find islands in here in grid 1? Like of the island is 1 in grid 1. That's it. So I'm not sure if we have to do this step one, because what's the point is of finding these islands? And if we can start with grid 2, we can find islands in grid 1, right? And just check, find island in grid 2 and just check if it's corresponding to, if it has 1 in grid 1. So, for example, I'm going through, found this island, DFS it, and checking alone if there is a corresponding in 1. And if everything I count as 1 island, then if corresponding found this sub-island corresponding to 1, I count this as island. The same here. So I'm searching this island, right? But see, this is example is very interesting because I would consider this as an island, but not all of it is in one. This is why it's not considered. Okay, so a new strategy will be DFS grid 2 and check if all islands in grid 1 and if all island cells is 1 in grid 1 and if they are considered it as sub-island, right? So will it work? So we'll go, this is everything is here, everything is here, everything is here. Not everything is here, so this is not considered as sub-island. So I think this should work. Let's go and do DFS. We can do visited or we can flip island to 0, but I would do visited. And it's a set. So what we're gonna do, we're gonna DFS island, and we will gonna have like some kind of return count, right? DFS island, and what we're gonna do, we're gonna receive some. First, we have to calculate edges. So rows will be. I think they're the same. They must be the same, right? So it doesn't matter. Rows will be len of grid. Calls will be len of grid 0, right? If this island will receive row and column. Also, we can specify directions, which is in which way we can do exploration, and we can do exploration in a way as -1, 0. So we can do so it will be row column -1, 0, 1, 0, and then 0, -1, right? And 0, 1. For direction. Yeah. And what we're gonna do, we're gonna, if we have, if matrix grid 1, grid 2, or let's pass grid as G. If G row column so if we have visited contains or we can say RC in visited, we just return because we're gonna have recursive call, and if row column in visited, we just return. Otherwise, if it's 0, if it's 1, what we're gonna do? We're gonna do recursive call and we can say and grid 1 and okay. So we found an island and we gonna first add it visited. And then I'm gonna call recursively for the direction. So R1, C1, it will be what we're gonna add. Let's call it R add and C add in these directions. We're gonna explore and call island with R plus R and we are passing grid, right? So we're gonna calculate in grid 2 and C plus C add. And here we have okay, so let's run it through how it's gonna work. So we find first value and its island, we add +1 and we add it to visited, and then we run for another one. And this is adjusted, so we shouldn't add, we shouldn't increase counter because this is still an island. So this should be like this. If we found, we increase for visited, right? If Yes, and then for every x direction we will go, and if this is equal 1 and we are not calling recursively, we will go and explore area, and if it's equal 1, then we just add visited, right? In this way we explore all 4 directions around, and add them to visited. Okay, so it's slightly different. So my goal is for like call it exploring row, exploring column, exploring row in, or like index in range from 0 to rows. I'm gonna call DFS if yeah, I should start writing from main procedure, not from DFS. If not invisited, and this guy, grid 1, grid 2, and grid 1, we increase breadth plus, we increase the return value plus 1, and we call DFS on red column. Grid 1. And this grid 1 will add visited to, so if it's visited, return, if it's then for every directions, we will call as the same DFS, oops, Let's go back to NFS. We do recursive call with the same grid, row column, and that's it. Okay, and at the end we return result. And should index R, index C, index R, index C, index R, index C. Okay, hashable type list. Why it's hashable type list? Because I should wrap it into one element. Because RC for some reason is list. Okay, let's print RC. Lights list. Oh, okay. That's funny. We also have to change for check for direction. So if for edges, if RC invisible or R So we have to check if r less than rows and more than 0, and C is the same with C, but in regards of columns, but it could be equal columns. Yeah, so this is and okay, let's submit it. Okay, and we have a wrong answer. Hmm. Yeah, I don't know what is the problem with this, and I'm out of time. So let's continue working on this and figure out next time in next part. Thank you for watching.